0.378. Okay. So from here we can construct a circle. Okay, I'm going to draw a circle. I'm going to sketch a circle. Okay. I'm going to sketch a circle. So what do you realize about this circle? It is outside the what? Red box. Agree or disagree? It is outside the red box. But that is not the biggest problem. We have to now use that point to construct our what? Our 3D mole circle. So if we were to say stress Y is equal to what? 156 point minus, okay, so this is minus. This is the least of our problem. Why? Because at the center, we know that we have another what? Point what? Z, yes or no? Right, we have another point Z. So now we will draw another circle. So 2, 3, 15, 1.5 out a bit. Now we have another circle. Right? So now this circle belongs to who? This circle now belongs to our what? XZ plane. And then the first circle belongs to who? Belongs to our what? XY plane. And the biggest circle is where? This is where the biggest circle is. Okay. And this belongs to our what plane? YZ what? Plane. Now, student has asked me this question very often. Is all the circle outside the shaded region? Answer is what? No. However, as long as part of the circle is outside the box, the structure will what? Structure will fail. As long as the box is outside the what? Sorry, as long as any part of the circle is outside the box, the material will yield or will what? Will fail. We fail. Okay. So the answer that we got is what? So stress Y is equal to what? Is equal to 15 minus 156.378. This is not the right answer at all. If you look the solution manual, maybe this. I don't see that number at all. They call it at 160. Okay, I don't know why they call it. Maybe a stress state is different. Okay. So ours is what? Let me check, okay? But you can see why they got it as 160. I got it at 156. I will check later on where I made the mistake. You see my mistake? Yeah. Hey? Where? That's 48 horizontal. The shear is correct. The shear is at where? 48. It's 48. And then we have 50. Let me check my formula, okay? It's embarrassing, but it's okay. So 73. So minus 50. Ah, I found my mistake. Ah, yeah, it's not the line. It's my number. I do apologize. Okay, so 73 squared minus 48 squared is equal to 55. So this will become 55 minus 50 plus by 55. So it's 5. And then the other value is 55 plus by 50 is 105. So from here, you have 105. So you have minus 105 plus by 55 or minus by 55. Is it minus by 55? Yeah, minus by 55. So it's equal to minus 160. The book is correct. I was wrong. Okay, I make mistake down here. This is where my mistake is. So now, can you see why, regardless, I will redraw the circle when I post the notes. Can you see why minus 160 is rejected now? Yes or no? Right? So if you want to go and work out the math, be my pleasure. Okay? But look at this. Is this easier? Yes or no? Just draw and boom, get your answer. You don't need to form all those equations. Okay? Now, let's next construct the other possibility. The other possibility is where the center of the circle is equal to what? 5. Okay, so I'll do that now. So again, we are going to draw more circle. Okay. The horizontal now. So we are going to go here. Minus 180, 160, 140, 120, 80, 60, 40, 0, 20, 40, 60, 80, 100, 120, 140, and 160, normal stress. And then we have our shearing stress. So we know that shearing stress, we don't need to go more than 80, 20, 40, 60, 80, clockwise, minus 20, 40, 60, 80, anti-clockwise. And then our limits is what? So if we go back, I can't remember. Our limits is 146 and 73. Okay, so I'm going to draw our limits. 146. And 73. 146. 146. And 73. So eyeballing 73. This is my eyeball for 73. And I'm going for 146. 146. 146, 73. Okay. And then 146. 146 is about 146, 73. And yeah, that's about 73 that you can get. Hold on. Okay, so we know that one of our point, we have calculated that one of our stress average, right? Stress average 2 is equal to what? 5, yes or no? Right, so now we are going to use the 5 megapascal now. Okay, we're going to use the 5. So we have minus 50. It's our normal stress for one of our element. And then we have 48 on left and right. So this is our 48. Okay. Then we have another 48. Okay. And then we have a 5 as our center. So this is our 5. Okay. So we know the next line. So we know that this is our point X and this is our point Y, right? So from here, we know that stress Y2, or I'm going to call this our stress Y2, okay? Our stress Y2 will be equal to plus 5 plus by what? Because it's going to the right-hand side, that distance over there is 55. So this is equal to 60. It should be 60. I'm getting more than 60. Maybe it's my line. So the stress average. I'm cheating a bit, okay? It should be on the 60 line. Yeah, it can be on the 60 line because of scaling. Right. So once you get over here, this is our 60 megapascal. Then once again, we have to construct our what? We have to construct our 3D mole circle to ensure that this solution is possible. Okay, so our first circle now. Okay, so this is our first circle. Okay. Then we know that point Z is over here. This belongs to our what? This belongs to our XZ what? Plane. And then the next circle, 2, 4, 6, 2, 4, 6, 6 and a bit. The next circle that I'm going to draw, 3, 3 and a bit. Okay, so this circle belongs to which plane? Anyone? Based on the acute angle, X is the acute angle, coming here is the acute angle. So this is our XZ plane. And then lastly, our last circle. So 2, 4, 6, 4, 3 and a bit. So now this is our last circle over here. And this last circle is our what? This is our Y. Our YZ what? Plane. We clear? So now you can see all the 3 circles are within the what? Are within the rectangular one. So the material is same. Are we clear? Not like the one before. If you pick the wrong stress state, right? You can see that the what? The circle is outside the what? It's outside the box. This is how you combine 3D mole circle with stress strain curve. With that, I see you guys tomorrow.